So we're graphing reciprocal functions. So I'm going to show you what the graphs look like first, and then we'll talk about why they look like that, I guess. Here's our cosecant function. Our cosecant function has asymptotes at 0, pi, and 2 pi. Oops, that should be the 1. So these dotted vertical lines are asymptotes. These are the graphs of our 3 reciprocal identities. And we could look at the unit circle and see why they graph like this. I'll explain to some extent where they come from. This first one, y equals cosecant, is the reciprocal of our sine function. And if we look at our sine curve, that looks like that at 2 pi. Our cosecant curve really reflects off of the humps on our sine curve. That's where it comes from. And if you look at a unit circle, right, we know this is 1, 0, and 0, 1, and -1, 0, and 0, -1. And we look at our sine values, we have 0, 1, 0, -1, right? 0, 1, 0, -1, and 0. Those are our sine values. So our reciprocal sine values would be the reciprocal of these. So the reciprocal of 0, right, that would be like 0 over 1. If I flip it, it would be 1 over 0. So it would be undefined. Right? Here, 1 over 1 is 1, so that works. Here's 0 over 1 again. So if I take the reciprocal of 0 over 1, that's going to give me an undefined value. So everywhere there's a 0 in my sine curve, there's going to be a vertical asymptote in my cosecant curve, because the inverse, or the reciprocal of 0 is undefined. Similarly, if I draw a sine curve, a cosine curve, right, to 2 pi, we see once again, everywhere we have a 0 in our cosine curve, we're going to have an asymptote for the reciprocal, right? Because the reciprocal of 0 is undefined. And then our secant graph, just like our cosecant graph, is going to reflect off of the humps in my cosine graph. That's where these values come from. And my cosine graph would really be like this. see where those are coming from. Our y equals tan x. This isn't going to be so helpful, really. We could look at the unit circle. In this case, you're just better off memorizing what our cotan graph looks like, right? Our cotan graph is, we could go around the unit circle and figure out these points. But just off the top of your head, cosecant reflects off a sine, secant reflects off a cosine. We have asymptotes at all the zeros, and you're better off just memorizing your cotan graph. It's kind of simple, right? But just two nice waves, and you have asymptotes every pi, right? Or every period. Right? This would be considered a full period, right? So here I have y equals -5 secant 2x. If we wanted to graph this, I always suggest that you label or identify your A and your B values, as well as your amplitude and period. And then this is a secant graph, so you want to sketch a basic cosine graph. Because this is secant, it's a reciprocal of cosine. And then you're going to want to label it. And then you're going to want to draw the humps as they reflect as a secant graph. So why don't you take a minute and try doing that? Oops. So my A is -5. My B is 2. My amp is the absolute value of -5, so it's 5. My period is 2 pi over B, so it's going to be 2 pi over 2. A cosine graph looks like that. I'm going to label it with the information I have here. I messed up, right? It's the negation of the function. This is where I always mess up. And it shouldn't look like that. It should look like this. All right, it has to reflect about the x-axis, so it's going to look like that. Now when I go to label it, I know the end of the period, end of the cycle is where I label my period of pi. My amplitude is 5 and -5. So that means this is going to be half pi. I know that everywhere there's a 0, I'm going to have an asymptote. And I know my secant graph is going to reflect off of these humps and run along the asymptote. So now I want to get rid of this cosine graph. I only used it as a template. and we only want to graph the secant. So I have pi over 2 here and pi here, and this is going to be 1/4 pi, 2/4 pi. This will be 3/4 pi, and then I have a point here. And I have a point here, and I have a point here. And that's what my secant graph would look like, right? From 0 to pi. You know, if this continued out to 2 pi, right, this would continue out. We would have more of this graph shown, right? But not necessary. And that's it for y equals -5 secant 2x. So this one's a little bit more challenging. We have y equals 2 secant x plus pi over 2. So in this case, it looks like we have a phase shift. So once again, I would write down my A, B, C, and D in this case, and my amplitude, my period, my phase shift. And even though I don't see it here, if I had a vertical shift, right, to begin this, you're going to want to identify those things. Since it's secant, you're going to want to sketch a cosine curve. Basic cosine curve, and then we're going to label it with our new period, and then we could apply the phase shift, and draw our graph, draw our secant graph. So it looks like my A would be 2, my B would be 1, my C would be pi over 2, and I have no D, or I could put plus D right there. My amplitude is the absolute value of 2, which is 2. My period is 2 pi over b. So it's 2 pi over 1, so it's 2 pi. My phase shift, I do negative CB, which would be negative C would be pi over 2 all over 1, so it would just be negative pi over 2. And my vertical shift would be my D value, which is 0, so it doesn't shift at all. If I was going to graph this, I want to graph my cosine curve. In this case, it's a positive curve. I want to label it. My period here is 2 pi. Therefore, this would be pi. My amplitude is 2, so I go as high as 2 and as low as negative 2. And now I have a phase shift. My phase shift is equal to negative pi over 2. So that means I have 1, 2, 3, 4, 5 points, and I want to move them over half pi to the left. Right? Well, even before I do that, I could, yeah, let's move it to the left. So if I'm shifting this graph to the left half pi, that means this point is going to be over here. Okay? The point that once was on my y-axis is going to be over here. I'm going to move it to the left half pi. And the same thing with my point that was at pi over 2 is going to move over half pi. So that's going to be here. And my point that was at pi is now going to be at half pi. And this will continue on. Oops, I made a mistake right there. I'm going to have a curve that looks like that. It's going to go from negative 1/2 pi to 3/2 pi. This whole graph shifted to the left, negative 1/2 pi. That's not the end because we have to draw a secant curve. So we got to remember that our asymptotes are at our zeros and that our secant curve reflects off of our cosine curve. So we're going to have one there, one there. So in short, that's what it would look like. And maybe you would erase your cosine curve. If you're using pencil, this would be easier. I'm messing up my whiteout tape. And there it is. So we started with a cosine curve, we shifted to the left, and then we put our reflections to make our secant curve. The end. Y equals 2 secant x plus pi over 2. That's what it would look like. What would that? How would we do that on a calculator, you ask? Well, that's a good question. Let me see if I can bring a calculator up here. So when you bring up your TI-83 or TI-84 graphing calculator, you turn it on. Oops, clear it out. Second, quit. You want to make sure, actually, I'm going to clear this whole thing. Second plus 7 to reset, 1 for all RAM, and 2. So now I cleared out this calculator. If you go to mode, you'll see you're in radians, which when we graph trigonometric functions, we want to be in radians. So that's good. I'm going to plug this in. It was y equals 2 secant. We don't have a secant button on our calculator. So we're going to use, should I put a parenthesis here? I'm not 100% sure. I'm going to put a parenthesis and do 1 over cosine. 1 divided by cosine. And then x plus pi over 2, pi divided by 2. And then I'm going to have to close that parenthesis, and I'm going to have to close the other parenthesis. I need 2 closing parentheses because I have 2 opening parentheses. I also want to check my window because we're going from, let's go from negative pi. Let's clear this. We're going to do negative pi to 2 pi. Let's go to 2 pi. And our amplitude was 2. And here we have 5. Let's make this 5. Make it negative. Make sure it's a negative, not a minus. -5 to +5. And then we hit graph, and hopefully we get a secant graph. Right? And we made our window from negative pi. So negative pi is here. So half pi would be here. And we went all the way out to 2 pi. Right? So we could close this window to make it exactly what we wanted. We wanted half pi. So we could do negative half pi, right, 0.5 pi, 0.5 pi to 3/2 pi. So that would be 1.5 pi. There you go. Perfect. That looks awesome. Nice job, Professor. Thank you. Stop sharing.